Good morning and welcome to the One Spatial free webinar program, where this morning we'll be talking to you and presenting on aligning your workflow for GDA 2020. I'd like to introduce the One Spatial Australia team with Andrew Bashfield, our sales manager, Simon Laird, our services lead, Emma Yates, marketing manager, Tom Farrington, senior consultant and our head trainer, Daniela White, sales assistant and also training coordinator. Priyantha Pelagama, or Pri, is our senior consultant and manages our support. Sam McDonald, senior consultant. Michael Studdard, a sales consultant. And Ashish Manandhar, senior consultant. And myself, Andre Makika. I'm the sales country manager for One Spatial Australia. And on behalf of the team, welcome, and we look forward to giving you information on how you can work with GDA 2020. Just a little bit of coverage on what One Spatial is. We're an organisation that work in the GIS or geospatial industry, and we are over 50 years of development and providing innovations to the profession. We are a global organisation with offices in the UK, with head office in Cambridge, Ireland, France, Belgium, US, and in Australia we have our head office in Sydney and an office in Melbourne, with sales, with our consultancy staff and our staff all across the eastern seaboard of Australia. We do partner with technology partners, as you can see, and in particular, we will be talking today mainly with regard to our ties with Safe Software, where we are the premier platinum distribution partner for FME. We work in a multitude of industries, working across military, telecommunications, utilities, etc. Who are we? We are a software solution provider and a global expert in managing location and geospatial data. We are striving to make the world safer, smarter, and more sustainable for our future. We help customers to unlock the value of their data to create a smarter world. We deliver powerful data solutions and applications on-premise, mobile, and in the cloud. We are a customer-centric business. We deliver solutions to address our customers' needs and market requirements. And above all, we collaborate with people. We provide a number of solutions, and we provide the One Spatial Management Suite. And as I mentioned earlier, we're also providing the FME suite of products, and today's presentation will be mainly concentrating on what we offer with FME. What I'll do now is I'll just play a very short video that gives an overview about GDA 2020. This video was put together by the ICSM a few years ago now, admittedly, so it is a little bit dated insofar as it was done prior to 2017, but I think it would be valuable for you to have a look and listen.
Many of the technologies that affect our lives and shape our built environments, from smartphones to farm equipment, all the way up to aeroplanes, rely on location information. All these technologies determine where they are in relation to known locations on the landscape. These reference points and their coordinate system of latitudes and longitudes is called a datum. Each country has its own datum, and the one that Australia uses now is called the Geocentric Datum of Australia 1994, or GDA 94. GDA 94 is fixed to Australia's tectonic plate, so wherever Australia goes, GDA 94 goes. All our mapping is based on the plate-fixed GDA 94 datum, but the technological devices we rely upon use a different datum to determine their location. These devices determine locations using global satellite systems, such as GPS, which are based on a datum that is fixed to the centre of the Earth. This Earth-fixed datum allows for satellite positioning to accurately reference locations on the Earth's dynamic surface. Australia sits on one of the Earth's fastest-moving tectonic plates. Since GDA94 was established in 1994, Australia has moved more than 1.5 metres northeast. Satellite positioning technology is evolving rapidly. By 2020, all Australians are likely to have access to affordable devices that can measure locations to an accuracy of 10 centimetres. That will cause issues unless something is done to ensure Australia's plate-fixed maps align with devices using accurate positioning. It's a big job, and Australia is addressing the issue in 2 stages. Stage 1 begins in 2017 and involves updating our plate-fixed datum to where Australia will be in 2020. Called GDA2020, it will define locations 1.8 metres northeast of GDA94. In the next 3 years, GPS locations will converge with features represented on our maps. Stage 2 begins in 2020, when we will be able to implement a datum that keeps Australia in step with satellite positioning technology. Australians are growing more dependent on location technology and stand to benefit from accessible, accurate positioning. But these benefits won't be realised unless Australia's datum is modernised. Awareness of the change will be needed in any sector that uses spatial information. This includes mapping, surveying, construction, agriculture, environmental management, transport, insurance, emergency services, telecommunications, and scientific research. To find out more about how Australia's data modernisation affects you, please visit our website at www.icsm.gov.au.
Thank you. Welcome back. And I trust that that little video gave you a bit of an insight into why we're doing what we're doing, the Australian government, and where we're going. What we'll be covering today is how your data, knowing your data and understanding the impact, which will be presented by Simon Laird, authoritative data sets that already exists, which will be presented by Michael Studdard, height datum and support issues by Priantha Palagama, transformations with FME from Tom Farrington, and how we can help implement the move by Andrew Bashfield. And on that, I would like to welcome Simon Laird, our services lead, to present on Know Your Data, Understanding the Impact. Welcome, Simon.
Thanks, Andre. Good morning, everyone. Thanks for joining us this morning. We can just move ahead one slide. So yeah, just a quick recap of the video there. So GDA 2020, it's a new modern datum for Australia. As the video described, as our country's tectonic plate shifts in a northeast direction, all our current coordinates, which we hold typically in GDA 94, are static despite ongoing changes to the Earth's landscape. This difference starts to become evident and an issue when using high accuracy GNSS. So the first stage of the adoption of GDA 2020 is the new GDA 2020 datum, which is another new static datum similar to GDA 94, but it is in line with the International Terrestrial Reference Frame at January 1, 2020. And then the second stage is the adoption of a dynamic datum, which is known as the Australian Terrestrial Reference Frame. And that enables data to be aligned in the future and accounts for the tectonic plate motion over time. And to adopt this, however, we need to capture some additional metadata containing of any measurement. Other things to consider, GDA 2020 is a horizontal datum, and there are no changes to the Australian height datum itself or any data that is held in AHD. However, if you're using GNSS for capturing height, there are differences between the ellipsoids in GDA 94 and GDA 2020, when it comes to capturing ellipsoidal heights from GPS or GNSS. And given this, there's a new geoid model to enable conversion from ellipsoidal heights, which you get from GPS, to AHD that's been released by Geoscience Australia, known as Oz Geoid 2020. And Pre will run through a bit later in the webinar how you can convert heights from GDA 2020 ellipsoidal heights to AHD, but also how you could migrate your data from or between the two ellipsoidals. So if you had GDA 94 ellipsoidal heights, how you can, if you needed to, calculate the GDA 2020 ellipsoidal height. So really, the use of location data in our organisation and the reliance we place upon it is ever increasing. Gone are the days where location data was easily characterised as being only relevant to GIS and CAD data and the professionals who deal with that data. Knowing how and where you use location data within your organisation or within your day-to-day life is important. So identifying the impact of this is the first step. Where do you use location data in your current organisation, and how will this change affect you? Smartphones, handheld GPS or survey GPS, fleet tracking devices, asset management systems, design and document management systems, and other platforms, just to name a few, are some, I guess, systems that we commonly use or commonly have more reliance upon these days that use location data. And it needs to be understood and quite well documented as to which datum they work within. Are they using GDA 94, or perhaps a projected form of this in one of the MGA zones, or perhaps is it simply using WGS 84 and no one really knows? Also, consider when you're reviewing your data, consider any legacy data that you hold and make sure it's well understood and documented in metadata what datum this is held in. So increasing awareness of this move and transition to GDA 2020 shouldn't mean fear and panic. Really, the aim of this webinar and the overall goal of GDA 2020 is to align our data onto a common, up-to-date and modern datum. So by this, empower users within your organisation and provide guidance and support to help them understand the impact of this change and what it will mean to them. As we've, I guess, shown in the ICSM video, ICSM themselves provide a range of reference material that suits a whole different level of technical understanding from users who perhaps don't know what a datum is and probably aren't aware that it actually this impacts them, down to geodesy level depths of knowledge. And a lot of this material we're drawing upon to help present today and also help customers make the shift. Finally, metadata. I probably should have put this at the top. Metadata is probably one of the most critical things that you need to ensure you hold, ensure it's current and up to date when it comes to managing your data. Now is a great opportunity to check that your metadata is correct for your existing data and to ensure that your processes are in place to update metadata as you make the shift to GDA 2020. And as we've said, this will become more important with the move to a dynamic datum, the Australian Terrestrial Reference Frame, as when that occurs, capturing the time or the epoch of when any measurements were made using GPS or GNSS becomes important. So when it comes to actually doing the transition, reviewing your existing data, whether it's operational data, archive data, or data that's held within your organization, or also incoming and outgoing data that you may have from other organizations, whether they're state authorities or other third parties that you perhaps submit data to, receive data from. It's important to consider these touch points as well. And the data that's being migrated or shifted, it's important to understand how your systems and your organizational processes will support this. So obviously the first step is reviewing the data you hold. The second step is really about identifying the systems within your organization that interact with and use this data to understand how these systems will be affected. So systems handling location data will need to be verified as to what datum they work in initially with your current data, but also as to whether they support GDA 2020 or perhaps require some upgrades or remediation to work with the new GDA 2020 datum. Other things to be mindful of: consider that the null transformation when working with WGS84. So by that I mean there is currently no transformation when moving between WGS84 and GDA94. And also the key things to identify from reviewing your current systems and will be, I guess, evident when it comes to planning your timeframes and your schedule for that transition to GDA 2020, as any custom-built applications, legacy systems, or any other systems that may or may not be necessarily supportive of GDA 2020 out of the box may require time to upgrade, remediate, or perhaps replace if it comes down to that. As with any change, bringing your stakeholders internally and externally to your organization and any users that will be impacted along the journey of this transition will be important to understand what the change is, how, and also when it will impact them. And then finally, after this, I guess, review and the plan you put together, implementation and transition will obviously be driven by the significance and the complexity of any systems that need to be upgraded or processes that need to be changed to handle the new datum. And obviously, with anything, proper planning will ensure the process is as smooth as it can be and captures all the necessary data and systems within your organization. And finally, updating metadata, especially as we move forward to the dynamic datum, is important. So on that, I'll now hand over to the others in the team, but please feel free to reach out if you do have any questions about how to make the transition as smooth as possible.
Michael Studdard, our sales consultant, to do his presentation on authoritative data sets that already exists. Welcome, Michael, and over to you.
Thanks, Andre, and thanks everyone for joining. So yeah, I'll be talking about authoritative data sets that already exist, and I'm sure a lot of you are quite familiar with. So the rollouts that are associated with GDA 2020. So as you saw from the video before, it was pretty much available, the specifications to the state authorities by January 2017. And the state authoritative members, all of them are members of ANZLIC, including New Zealand, and that was set out that the data has to be delivered in GDA 2020 by June 30 of 2020. So that also means that the ANZLIC members must also support receiving data in GDA 2020 if you have to make your submissions to them. And also just something important to notify is also that the AusCores base station locations, those corrections that they do to the GPS points are now referenced in GDA 2020. So moving on to the authoritative data sets across the country. So this is just a little bit of a picture on when these organizations made the data available in GDA 2020. So of course, you see not all of them were in 2017. It took some of them to roll out. And with ACT, that is available in 2020. I just couldn't exactly find when they released it. And then with Northern Territory, it looks like it's not available as of yet, but will be soon. More to come from them on that. And so the general move to GDA 2020, it has been quite gradual. So as you could see from there, it wasn't all available straight away. A lot of these land authorities are doing it in phases. So there's different parts that are released in GDA 2020 over a couple of years. And a lot of these places will be supporting GDA 94 for the near future. From what I've seen, Spatial Services in New South Wales is the only one saying that it will be unsupported by 2023, but that there is time, and I guess with 94, a lot of places are still supporting it, and haven't come out and said when that will be closing off. So the transformation guides that you can find and some technical help on that, there's a lot of it on the Geoscience Australia webpage. I guess they're the ones, the government authority that looking after and kind of looking after this rollout. So they've got a lot of tools on their website, and the ICSM has a lot of information to do with this rollout as well, which you can see from the link there. It's quite extensive. It summarizes a lot of the information that I have here. So if you are looking for a first spot, I do recommend the Geoscience Australia page and the ICSM page. But yeah, there's not too much else on that. I'll let it move on now, and I'll take it back to Andre.
Thank you very much, Michael. I would like to now welcome Priyantha or Pri to present on height data.
Good morning, everybody. So let's look into height, because it's a hot topic relevant to GDA 2020. Yeah, let's move in. So what's height? It seems a simple question, but as GIS users, you all know it's not that simple. So I know that you all know more than enough about datum, Australian height datum, and how to calculate height with them. Therefore, I'm going to focus on few practical issues we face with height when moving your data into GDA 2020. Starting with basic, in most cases, we refer to the height as the height from AHD, or the Australian height datum. Yes. So if this is the point that we consider above the Earth to measure the height, and yeah, if this is the Australian height datum, and we measure the height h from Australian height datum to that point above Earth. So, however, nowadays we use global navigation satellite systems to collect data. So those global navigation satellite system use an ellipsoid different to HD. For example, if this is the datum used by the GNSS, so then the height measured from that particular datum is different to the height from HD. So if we consider it as E, there's always an offset between the ellipsoidal height and the HD. Usually we refer it as N value. So the problem is this N value is different from point to point, because the AHD could go closer to the datum that we referred, or sometimes it can go below or above the datum that we referred. So it could be this N value could be positive or negative depending on the location. So therefore, there should be an easy way to resolve this issue. For that, we use the ostioid as the solution. So ostioid is a model that we can use to convert ellipsoidal height to HD height and vice versa. So we can apply this ostioid model at any point to calculate this offset between the ellipsoidal height and the HD height. Even though it looks simple, as I mentioned previously, with the advancement of technology, the ellipsoid is updated to get precise positioning. The most recent update is GDA 2020. So once we change the ellipsoid, it changes the ellipsoid height and in a given location. So for example, if this is GDA 94 and GDA 2020 is different to GDA 94, and the offset between these two different ellipsoid and the AHD is different at a given point. So therefore, we should use different ostioid model for each datum to calculate this offset. For example, for GDA 94, we can use ostioid 09, and GDA 2020, new model ostioid 2020 is introduced. So to summarize this, what we talked about in the previous slide, it is possible to convert height from GDA 2020 ellipsoidal height to AHD height and vice versa using ostioid 2020. And same as for GDA 94 and AHD height using ostioid 09. However, there is no model to convert ellipsoid height between GDA 2020 and GDA 94 directly. So this seems confusing for many users. especially being able to convert horizontal coordinates between GDA94 and GDA2020 using transformation parameters or grid. Sometimes users expect to convert ellipsoid height between GDA94 and GDA2020 directly. So that's a thing that we need to remember. So if we apply GDA2020 to convert ellipsoidal height to HD height, so it should always be we need to use osteo 2020, and using osteo 09 we can convert the height calculated from GDA94 ellipsoid. So if you, in any case, we want to convert ellipsoidal height from GDA94 to GDA2020, you need to convert it first to HD using the appropriate model, and then convert it back to GDA2020 using osteo 2020. And the other thing to remember is, if you have already calculated the HD height in data that you collected using GDA94 ellipsoid, then again you don't need to recalculate it using GDA2020 ellipsoid, because you have already calculated them using GDA94, and you cannot achieve any more precision or accuracy using converting them into GDA2020 and back to HD. So then you can, in that case, you can just convert the horizontal coordinates and you can keep the HD height as it is. As an example, this is a screenshot received through our support channel requesting support to convert height from GDA94 to GDA2020. Still working on this one. So in this case, again, the user is trying to convert HD height. The source, the data is collected using GDA94, and is converting GDA, so the HD height into ellipsoidal height using osteo 09. And then try to apply the osteo 2020 to convert that value to HD. So that doesn't match with this diagram again. So that won't work. So we'll get incorrect value in that case. So one special consultants team is more than happy to assist you in any issues relevant to data migration from GDA94 to GDA2020. So that's the basic about this converting the height, and that's all about the osteo 2020 and the height module that we using convert GDA 2020 ellipsoidal height to HD. But however, the osteo is not the end of the story. At present, certain applications like automated navigation systems in vehicles create demand for more accurate calculation of height. Therefore, require 1 to 8 centimeter accuracy. New geoid surface named Australian Vertical Working Surface has been introduced. To convert height between GDA 2020 ellipsoidal height and Australian Vertical Working Surface, we can use Australian quasi-geoid model. So I know in most cases, HD height is more than enough. So you may not interested in AVWS at present, but that will be a thing to consider at some point in future. So that's about height. Thank you very much.
Thank you, Pri. And I will now like to invite Thomas Farrington to the stage, if you like, to present on his topic of transformations with FME. Welcome, Tom.
Thank you, Andre. Welcome, everybody. So yeah, I'm going to briefly talk for a few minutes around how we can perform our transformations within FME. Okay, so reprojecting our data to GDA 2020 using FME, we have two main transforms for the horizontal coordinates. We have the 7-parameter transformation, which is a conformal transformation, and then we have the grid transformation, which includes distortion, and this leads to a more accurate transformation. Now, within FME, you're probably aware that we can reproject data just in the navigator window. So when we read data in, we have a coordinate system on that data. We can then specify a different coordinate system on the way out. So when it gets written, FME will automatically reproject that. For this particular translation into GDA 2020, it's going to use the 7-parameter transformation by default. If we need to use the grid transformation to take it a bit to get a bit more accuracy into our data, then we're going to need to use the reprojection transformers that are available. I apologize for my dogs. So with the transformers, we've got 4 main transformers: the reprojector, the proj reprojector, which is the open source proj algorithms and transformations that are available through things like GDAL and so on. We have the Esri reprojector, which is basically using the Esri the Esri transformations and so on, so you can be consistent with any other data that you are reprojecting if in the Esri suite of software. And then the last one we have is the CS map reprojector. All 4 of these will transform at the 7-parameter to do the 7-parameter transformation for us. Only the last 2, the Esri reprojector and the CS map reprojector, will allow us to use the grid transformations. So let's move on a page. Oops. There we go. So using the grid. So yes, for the 2 transformers that we can use a grid-based reprojection, we can use the Esri reprojector or the CS map reprojector. Both of them were doing exactly the same transformation, GDA2020. Both of these we can use the grid as well as the 7-parameter. We get the choice, so therefore we can be using the distortion version of the grid. However, if we need to use to do some work with the vertical handling, as Priyantha was talking about, then we do need to use the CS map reprojector. That gives us options there. The other thing to talk about is our attribute reprojection. So yes, we've reprojected our geometry, but many data sets will also store like an X and Y coordinate in the attribute table, and we can reproject those as well without having to convert them to geometry and then back to attribute values. So we have 3 transformers here in FME to do this. We have the attribute reprojector, the proj attribute reprojector, and the CS map attribute reprojector. They're pretty much the same as their geometry counterparts, but they do the reprojection in place. So if you need to retain the old values, say the GDA94 values, then you will want to copy GDA94 into a new set of values, maybe labeled 2020, and then do the reprojection on those. Again, we get the choice between going between 7-parameter or grid transformations. Again, it's up to you which ones you need to employ for the quality of the data that you've actually got. And as with the geometry ones, as we get up towards the CS map version of the transformers, these are the ones that get the most control and the most refinement over the transformation that we're going to use. And I think that's about it for me on the FME side of things.
Thank you very much, Tom. I will now like to move to a presentation from Andrew Bashfield on ensuring you have a plan for the transformation.
Terrific, Andre. Thank you very much. Simon walked us through the issues to consider for planning the move to GDA 2020. He mentioned the data review, systems and process review, and the education of the users and stakeholders, and also the technical side of the move. But I want to pose the question, are you actually resourced to make the move yourself? Do you have the knowledge to get it right first time? Have you documented your plan? Do you have the staff availability to carry it out without impacting your operation? So what I'm going to explain is how can One Spatial help you achieve that? So first of all, you want to make sure you upgrade your FME version if you're running something that's quite old. One Spatial can also assist you in reviewing your data sets to build the transformation plan. We carry out FME basic and advanced training all the time, every month, and that training can assist you in using FME to transform the data to GDA 2020. We can assist you in implementing a transformation workflow in your organization. And if you need to, we can actually carry out the transformation of your data for you. So whether you need advice or work carried out, or you just need support, One Spatial is here for you. Just give us a call or email and we'll guide you through.
If you have any more questions and you haven't asked them online, please send them through to support@onespatial.com or to sales.australia@onespatial.com, and we'll be happy to answer them. I'd like to now just conclude our presentation, and in our conclusion, I'd like to highlight that you need to understand your systems and your needs with regard to GDA 2020. There is no one size that's going to fit all situations. Everybody's situation will be different. Heights depend on geoid models used, so it is a trap that people need to be aware of. FME provides the tools that you need to be able to do the transformations of your data sets. And it's not difficult. It just isn't easy. And last but not least, the potential ramifications of doing nothing. So what I'd also like to now do is talk to you about and introduce that we will be doing our last free webinar on the 10th of December between 12 and 1, and the topic will be lightening your load with FME Server. Please go to our website and have a look at the agenda of what's covered. We look forward to seeing you there. We'd like to take this opportunity to highlight again that One Spatial Services sell, support and train. We are the premier FME Platinum Partner, premium MSP for FME Cloud. We have a dedicated support team providing you FME desktop, server and cloud products. We have a skilled set of FME accredited professionals with professional server and trainer qualifications. Our services include facilitating product evaluation, providing consultancy services. We undertake public and bespoke training services. Admittedly, at this point in time with COVID, our public training is done via online, but we do look forward to going back to face-to-face, hopefully in 2021. But stay tuned on our website to know more information as required on our training. And we do have our technical support at onespatial.com, or through our 1300 number, 1300 290 686. And on that, I'd like to close our webinar. Thank you very, very much for your attendance. And if you want to get in contact with us at sales.australia@onespatial.com,